start. The recording has started as well. And let's look a bit at chapter 6 and hopefully 7 as well. So chapter 6 and 7 is looking at normal distributions, and then chapter 7 takes that normal distribution a bit further and looking at when we're looking at sample distributions, but it will be then a sample distribution for a normal distribution. So I think that is just important. It's chapter 7 basically looks and makes chapter 6 a bit more fuller. So the information that we're doing and using in chapter 6, we will refine it a bit and use it in chapter 7 as well. Okay, so then a few things that I thought is again important, and as I shared previously with other presentations, and we saw it in nearly the previous session today as well. Just some of those words that we love to use. We're going to see it in chapter 6 and 7 a lot as well, where they use more than, less than, all those types of things, so that we just have that view as well. Then, and this also links to some of the earlier questions about empirical rules. So, but again, I will still add that into our last session, and all other questions. But basically, we look at the normal distribution, which is bell-shaped curve. There's some properties around it that we always look at. So we'll say the mean, median, and mode is exactly the same, so the data is not skewed. Then we will say, if you look at that mean, half is on the left of it, half is on the right of it. Everything underneath the curve is always the probability of that is equal to 1. But then what we also sometimes do and talk about is to say, well, around the mean, if we move one standard deviation away from it, we will capture around 68% of the data. When we move a bit further away from it, so we say within 2 standard deviations, we cover 95%. And then if we move a bit further, 3 standard deviations, we look at around 99.7%. So you guys can nearly get a feel again if we look at that table and we use Z as 1,645. Remember, we're talking about 90% that it then refers to. When we talk about Z 1,96, so very close to 2, it's for 95%. When we talk about Z is equal to 2, what is it, 5, 8, I think, or something like that, we talk about 99%. So nearly you can see that it's very much in line with 1,96 with a 2. The 2, I think it's 2,58 or something like that will cover 99%. So that's also why these are much in line with what those tables are. But we would rather use the tables of a 90% that's equal to 1,645, the 95, and the 99 instead of these numbers. Okay, we've done that where just the symmetry around that mean. that is important when we want to use the Z tables. Then what also is important is the formulas that we're going to use. So what I've done here is go straight into the chapter 7 formula of that. If we're looking at chapter 6, where we're not looking at sample sizes, the only thing that will disappear is the n. So that for me is the one thing that's important that we need to know. The other thing that you guys might ask as well is to look at the standard error when you need to work that out. The other thing that might pop up is this notation where x is normally distributed with a mean and basically the variance. So just keep that in mind if I use that notation in any of the questions. So the z-test is the x minus mean divided by that. So that's the one thing that's important. Then when we get to proportions, again, a z-test, but it looks a bit different. But also then just important is, again, the standard error. So that's the one. And then if it is unknown what the proportion standard error is, we will just use the p-value. So just again, those two things that is important. So let's look at a few of these questions, because again, I think that is where sometimes one gets caught up in all the detail. I just want to see where is my study guide that I can just get to. Not the study guide, the tables, and we're going to use two normal distributions. Okay, so I will just bring that into when we need to find. Okay, so let's look at this. So the first one that we're working with is, which one of the following is incorrect with regard to standard normal distribution? So that first one, we will need to work out if the z is bigger than 0,5, bigger than 0,5, so we will need to work out that component. So let's look. I can look at this table where that is minus 0,5. Let's quickly check. Minus 0,5 we'll get 0,3085. So basically saying, because it's symmetry, those two needs to be exactly the same. So that area is 0,3085. What we can also do is say, to get this area, we're going to take that hole underneath, which is equal to 1. 1 minus this red, sorry, not red, 1 minus this orange component will give us that red component. So that is another way of looking at it, is to say, well, we know everything must be underneath that must be equal to 1. So if we want to get to that red component, we say 1 minus what is in the orange. So for that, we can use this one where that is now the orange component. We look for 0, 0.5, where it is 0, 0.6915, 0.6915, and then the red component will be equal to 0, 0.3085. And so that is two ways that we could have gotten to that answer. And then, actually the second one, the probability of Z equal is the same as 1 minus that. So we've actually answered that in that question, actually. Probability that Z is equal to 0, 0.5. So on this spot, remember, normal distribution is continuous distributions. So with a continuous distribution, we can't get the value of something that is specific equal to a number. So there is no probability for Z equal to. If it was discrete, then it's different, because discrete is for 0, 1, 2, 3, 4, and 5. Continuous, you actually don't know, because it's a continuous distribution. Okay, so we're still looking for the incorrect one. Okay, so let's then see. Probability Z bigger than minus. So let's just again sketch it out. There's for 0 bigger than minus 0, 0.5. Okay, smaller than. So it's basically looking at this component. So is that equal to, let's see. Okay, let's just quickly do this better. Z smaller than 0.5. Okay, so let's do that. Z smaller than 0.5 is everything. Minus Z smaller than minus 0.5. So we actually take that component away. So what, let's quickly do that. Number colors. So that is everything smaller than 0.5. We take away this component, because that's the minus 0, 0.5. So what we left with is everything between minus 0.5 and 0.5, which is what we have here. So that is also correct. Now this is a weird one, so let's just then check. Last one is Z smaller than 0.5. Is that equal to Z smaller than minus 0.5. Okay, so that's the one that is not right, because that's not equal. So here you have that whole extra area that's not included in the second component. Okay, so again, question like question 1 here, I like to draw it out for myself. You could also do it a bit differently. So again, whatever is easiest for you, you could have gone and say, like this one, okay, get that probability. Then you could have said, okay, Z smaller than 0.5 gives me a probability. If I subtract that probability, I get the two probabilities. They're the same. They are correct. So you can do it via drawing it, but you could also go and actually physically work out what the probability value is. And with a question like this, everything is around the 0.5. So you would have been able to use the 0.6915 and the 0.3085 in most of these calculations to also work it out. Okay, so let's look at now going into a bit of the detail where we will need to work out with the Z formula what Z is, and then we will need to look at the Z tables and identify it on the Z table so that we can get to the right answer. So let's see what they tell us. A random variable X is normally distributed with a mean of 85, standard deviation of 20. Calculate the probability that X is at most. Okay, so let's first at most. So that X is at most. It is at most, so 95. Okay, so 95 divided by or minus 85 is 10. 10 divided by 20 is again 0.5. So working nearly with the same numbers as we did here. So what's the probability that Z is smaller than 0.5? Smaller than 0.5 is that whole area. Remember, we've seen that whole area in the previous one is 0.6. Where does it again? 6915. Let's just quickly go to 6915, 0.5, 6915. 6915 is option C. Okay, I'm just going to just quickly wait and save because probably my PC needs a good reboot. Okay, let's just open the presentation again. Yeah. Okay, so that was what we did in question 2. Basically worked out what the Z was that we needed. Get that Z, go to your Z table, to work out the probability. Okay, so the probability was 0.6915, which was that option 3. Okay, so let's go into another one. Now let's see what they ask us. Again, we will need to work out the probability. So we need to work out the Z. From the Z, we will go to the table. So let's just again see with the wording and the information what they tell us. A local company manufactures rechargeable lights with a mean battery life of 80 and a standard deviation of 8 hours. What is the probability that a randomly selected light will have a battery life of at least? Okay, so let's see, at least is greater or equal to, and that is 72. So 72 minus 80, that's minus 8 over 8, so bigger or equal to minus 1. Okay, so that is 0. That side is minus 1. So we want this area. Bigger or equal to minus 1. So what I would do is I would say 1 minus this orange component. So whatever that orange component is, 1 minus that orange component will give me what I need. So I would look at minus 1. Let's check minus 1, not 0.1, but 1 minus 1, 0.1587. So that is 0.1587. Just important, it's not that one. It is 1 minus 0.1587. So they are trying to catch you out with that. If you work that out, you think, great, I've got the number, but then they catch you out a bit. So 1 minus 0.1587 gives us that red area, which is 0.8413, which is option 3. So again, just be very careful. The pressure in the exam is, you guys will know that it is tough. So it might be very easily that you see this number, you see it there, and you say, oh, great, I've got it. But then it's actually, you need to do one more step with that. Okay, so let's look at a question that they also love to ask. It's a bit different. So consider the information from the previous question, but they give it to you again. Remember, rechargeable lights have a mean battery life of 80 with a standard deviation of 8. Suppose the local company manufactures the lights for a lighting warehouse. It's observed that the warehouse rejects about 20% of the lights. Determine the minimum value for battery life accepted by this lighthouse. Lightning warehouse. Okay, so we basically need to work out what is that X. those that rejects about 20%. Okay, so how are we going to work out that X? So if they reject about 20% of it, interesting, will that component equal to 20%? So that we can get a Z there. So let's quickly check if we can do something like that. 20% is with somewhere where it's actually so that's probably the closest to 20% is minus 0.84. Will that work? If we set 0.84, let's quickly check. We need to multiply that out by 8, so 0.84 times 8, that is 6.72 is equal to x minus 80. That 80 goes over. So let me see, this is now where to which side do we look at the 20%? That is 0.84, so sorry. 8 times that, 0.6. So we're looking at this minus 0.84 minus 0.84 times 8 is minus 6.72. That goes over so that we can complete the formula. Plus 80, it's equal to x. So x is equal to, what is 80 minus 6.72? 73.28. So we are looking only at this component, because otherwise it would have had a rejection rate of 80%. X equal to 73.28. Determine the minimum battery life accepted by the warehouse. And so again, now it is I again don't like these answers, because it is observed that the warehouse rejects because we do not pass the minimum. Determine the minimum battery life accepted by the warehouse. So I would actually have gotten to say the minimum would be 74. So I would have gone for the minimum is option C, because if it is 73, it is still rejected, because up until 73.28, I'm rejecting it. So 72, I'm rejecting. 73 I'm rejecting. 74 I will accept. 75 I will. So if there was a 73.5, I would have accepted it. I don't like this because normally how we will think about this question specifically is you will round it off to the nearest number. And that's why I first wrote 73, because that is how we typically think it, round it off to the nearest number. But that 73 still falls in the rejection area that I'm not going to look at it. I really don't like this question now that I think about it again. It's not, because you could have done everything up until this point correctly, and then humanly, we would round it off to the nearest number, then you will round it off to 73, but with that, we will make a mistake, unfortunately. Okay, so let's get into another one where they use a bit of notation as well. So here they didn't need to tell you this first component. They didn't need to add that because here they already told you the mean is 75. So they already have given you that piece of information. So they've told you that there's 75. They told you population standard deviation is 10. Okay, so this thing in words, they could have excluded it because it is all captured in the X is normally distributed with a mean of 75 and a standard deviation of 10. So that's already captured in that short form. Then they tell you, suppose that a sample of size 20, so there we go to complete that, selected from the population, what's the probability that the sample mean is between 70 and 74? Okay, so basically what we're going to add here is going to be a 70, and then we're going to put in a 74 as well. So we're going to look at the 70, which is going to be somewhere here. 74 minus is also going to be negative. So that's probably going to be somewhere here, and we will need to work out what is that probability. And so just by looking at what we need to work out, I can already tell you guys that this component is going to be less than 0.5. Okay, because it's all lying to the left of a 0. So when I'm looking at answers, yes, might be, probably not, but let's not eliminate. Definitely not. Definitely not. Okay, so if you need to guess in the exam, very much easier to guess between 3. If you look at how we've drawn it, probably between A and B. Then just how I'm thinking, I have not worked out anything. If I look at that and that, it's like if I add the two together, you can get to 1. So it might be, by not looking at any working, that I would have guessed that one. Would have been might wrong, but that is if I didn't have any information. But let's look. So let's first work out 70 minus 75 divided by with 10. Okay, so let's, again, I don't have my calculator with me. So let's just work that out. 70 minus 75 divided by 10 divided by the square root of 20. Sure, what? No, let me just see. So that's what I made my mistake. Okay, so I get, and please just, if you guys are also looking at it, minus 2,24. So let's minus 2,24, 2,24, sorry, 0,0125. So that's where that came into play. 0,0125 is this component. Um, it's this component. So if I have the 74 one and I subtract that one, I can get to my answer. So let's just quickly work out the other one. 74 minus 75, then divided by that is frustrating. Okay, so let's do that. And that is equal to minus 0,45. Okay, minus 0,45. So let's look at what is that whole area. Minus 0,45 minus 0,45. Let's just see. 5, so it's 45, 0,3264. 3264. Okay, so I would have been wrong in my guesstimate. So that whole area is 0,3264. So the area that I need to get to is the 0,3264 minus 0,0125, and that will be equal to 0,3139. Okay, so don't follow my shortcut because you would have been wrong like me. So our answer is 0,3139. Okay, so basically get the one for 74, the probability, get the probability of a 70, subtract the 2. Please don't go and say minus 2,24 and subtract minus 0,45 and get a new z and then go to the z table. So please don't do that. Work out the probability of a one, work out the probability of a second one, and then you subtract. Okay, don't subtract when you are at the z. So that was the one where x was equal to 70, and that was the probability where the x was actually equal to 74. So if you subtract those two probabilities, you would have gotten to option A. Okay, so let's go into the next. 2 or 3 is around the proportions. So in chapter 7, we look at the proportions. Here they want us to work out the standard error of a proportion. So let's look at what they give us. In a random sample of size 49, the sample proportion of interest is 0.75. Suppose that the true population proportion is known and is equal to that. Okay, so we know the true population. So here they tell us the standard deviation when X or when that is known. So it is known. They told us it is known. So we're going to use that formula. And so again, let me just get my Excel. So I'm just going to work it quickly out again. 0.8 times 0.2 divided by 49. Okay, so I get that answer is, and let me just quickly round it off to, what was it? Okay, so there it is 0.0571. Okay, so just be careful with a question like this again, because they've given us the sample proportion. So if you did use the sample proportion, let's see what your answer would have been. So 0.751 minus 0.75. So I'm just going to quickly change that in this formula. 0.0619 and see where it is. So if you read this, you used that, there is an answer for you. So yeah, please just make 100% sure that when you look at this, that you work it out, correctly, because again, there is an option if you actually have gone for where it's unknown, but everything here they tell us it is known, so you don't go with this one, because known, you use this formula. If you don't know what the population proportion is, then it's different. Then you use the sample one. Okay, so let's look at the next one. So here we are going to look as, what was it, the previous, where we looked at the 70 and 74, we need to look between two. So we're going to work out the Z, but we're going to look between two proportions. So consider the following application, exercise, advisors, contact, blah, blah, blah. Okay, that's just motion. 40% of advisors claim to have been a victim of click fraud. Okay, so we've got the 40%. So in this one, we're going to say 0.35 minus that. And on that side, we're going to say 0.48 minus that. In both instances, we know that is going to be 0.4. 1 minus 0.4 is 0.6. So that's going to be exactly the same for both. and then our N is a sample of 300. Sample of 300. And then if I quickly just do this, you can see the one side is going to be negative, the other side is going to be positive. So we want to get a value for the probability between those two. So if I look at this, those three, no, it's too difficult to really call. It feels that those are way too big, but yeah, I really don't know until we get to those. But the one will be negative, one will be positive, and that might just be way closer to one another. So let's work it out. So again, I don't have my calculator, so 0.35 minus 0.4 divided by the square root of 0.4 times 0.6 divided by 300. So if I look at just this, let's just make it bigger so that you can see what I did. Okay, so there's the 0.35 minus the 0.4 that's on top, divided by the square root of 0.4 times 0.6 divided by the 300. So that gives us minus 1.77. It's just because that's how we will need to go on the table. Minus 1.77. Okay, so that is a bit differently. It's going to be very small there. So let's look at the 0.48. I'm just going to that. The only difference now is that is 0.48. All the other things is the same, 0, or 2.83. So on this side, 2.83. Okay, so that is going to be probably one of the small, or one of the bigger ones. So let's look at how we're going to do that. So we get a value for the 2.83 because that covers everything. So we get a value for the 2.83 that covers everything. Then we get a value for the minus 1.77. If we subtract those two, we will get that black component in the middle that we're looking for. Okay, so 2.83. Let's go to the positive. 2.83. 2.83.9977. And we will probably, 0.9977. Look at that. Then minus 1.77. Let's look at the minus 1.77, but we want that area. Minus 1.77, 0.0384, minus 0.0384. It is. And if we subtract those two, we will get 0.9977 minus 0.0384, which is 0.9593. 9593. Okay, so in this one, they actually have given us all the ones that we needed to work out, but again, that is very difficult to just really see from what we're doing that it is going to be those probabilities. Okay, but again, try to write it out for you so that it's just sometimes simpler to then see what you need to do and what you need to subtract. Okay, last one. So let's look at the last one. Consider information from the previous. Okay. Once again, assume a population proportion of 40%. Suppose now that a sample of 200 is taken. Okay, so what's the probability that the sample proportion will be at least? Okay, at least it's that one. So Z bigger equal to 0.42 minus 0.4, and then we just do this component. It's the same, but the sample is now 200. And so the first thing I see again is, if I look at this, 0.42 minus 0.4, it's going to be a positive number. And I need to work out the bigger. So already what I see here is, okay, that is 0.5. So this component is going to be something that's less than 0.5. So when I look at this, cancel out, cancel out, cancel out. So guess between two numbers and not between five numbers. Okay, so let's see what the Z is that we need to do. So again, let's copy that. I just want to see. So now we work with 0.42 and the sample was 200. So now we work with 0.58. So if we then go to our table, I want this component, so we can look at what is 0, or minus 0.58 would have given us 0.281, 0.281. So that is what, or we could have said 1 minus this area. So 1 minus the green area, that's in the positive. So let's look at 0.58 for positive, 0.58, so 0.719, which was, there was a 719. And if we subtract those two, we will also get to 0.2810, which is the same. So there is, again, you can go to the negative table and get the 0.281, or you can go to the positive table and subtract the two and also get to 0.281. Okay, so that was a quick run through of study unit 6 and 7. So we will have a session on Monday again to look at study unit 8 and 9, and a session on Tuesday to look at study unit 10 and 11, so that we just go through all the prep with you guys before you write. Okay, so those two, there will be two more sessions that we will do, so that we just cover everything for you. Okay, so that is it for today, guys. I will share the two recordings